Hello, hello. Welcome back. We are doing 3.2 today, and I shut all of my doors, so hopefully we don't have any squirrel interruptions this time. Okay, so continuing with solving systems of equations, we looked at graphing method in 3.1, and we saw how in that last example that graphing may not be the most precise method. So we are going to look at two methods here in 3.2 on how to solve these systems algebraically. Okay, so take notes, have your phone ready for questions, and use the closed captioning button down below if you want some subtitles. All right, solving systems algebraically. So I break this section into two videos. In this one, we will look at substitution method, and in part two, we will look at elimination method. Okay, so we already looked at graphing method. And we said that this one here is not always precise. Okay, so we are going to look at substitution method, and we are also going to look at elimination method. Okay, so these are the two methods that are algebraic, and these are precise. Okay. All right, so again, we're going to look at substitution method in this video, part one, and then part two video, we'll look at elimination method. Okay, so substitution method. Okay, so in order for you to use substitution method, we need one of the equations solved for one of the variables. Okay, so for example, if we have this system, 3x plus 2y equals 8, and y equals negative x plus 1. Okay, so we see here that this second equation right here, this one is solved for y. So this one we could use a substitution method right off the bat. Okay, because this one here, this is solved for y. But it doesn't need to be solved for y. It could be solved for x. So maybe you have a system that looks like this, 3x plus 2y equals 8, and maybe you have the second equation says x equals, and that's fine too. Okay, this one is solved for x. Okay, so you just need at least one of them. You could have two equations where one says y equals 2x plus 3, and then the other one says y equals negative x plus 1. That's fine if you have both of them solved for y, or both of them solved for x, or one solved for x and the other one solved for y. You just need at least one of them. Okay? Now, so suppose that you don't. Let's have a look at that. All right, so if not given one equation, solve for one variable, then rewrite one so it is. Okay, so I'll give you an example. So if you have a system that looks like this, 3x plus 2y equals 8, and 5x plus y equals 7. Okay, then so here we don't have one of the equations solved for one of the variables, but I could easily take this second one and rewrite it so that it's solved for y, so that the y is by itself. Okay, so that's what I would do here. So I would take this one here and I can rewrite. You can rewrite either one. This is the easier of the two equations, in the sense that here, to get the y by itself, you just have to subtract 5x. Whereas this one, if you want to get either one, the x or the y by itself, it takes 2 steps and you introduce fractions. Okay. All right. So since this is already 1y, I'll get this lonely little 1y by itself. So we can rewrite solving for y. And if I do that, then I would get y equals negative 5x plus 7. Because to rewrite this, I would have to rewrite this so that the y is by itself, I would need to subtract 5x on both sides, in which case I get that. Okay? All right, so hopefully one of them, at least one of them is given. If not, hopefully you have one that is easily to rewrite. Okay? And then and usually if you don't, then I would use the other method, which is elimination method. Okay. All right. So once one equation is solved for, then you can substitute. Okay, substitute this into other equation. Okay. And we are about to do an example. So if you're confused about what this means, you'll see it in a second. Okay, so let's take a look at this one. Let's solve by substitution method. Okay, suppose I have this system, x plus 2y equals 4, and 2x minus y equals 3. Okay, so I can't use substitution method right off the bat because I don't have an equation that is solved for one of the variables. Okay, however, I could choose one of these to rewrite. So I could choose the first one and rewrite it so this x is by itself. Or I could choose the second one and rewrite it so that this y is by itself. Okay, and it doesn't matter which one you do. At the very end, everyone should get the same answer. Okay. All right, so I'm going to choose to rewrite this one. All right, so we can rewrite, and we do this by solving for x. And so x plus 2y equals 4. So x equals negative 2y plus 4. Okay, so in order to solve for x, I have to subtract 2y on both sides. Okay, so here I have this. So right here, I have my equation solved for one of the variables. So now I can go ahead and use my substitution method. Okay, and so this last step right here, once one equation is solved for, substitute this into the other equation. So here I have this first one solved for x. And so now I can replace the x in the other equation. I can replace this x with negative 2y plus 4. Okay, because x is equal to negative 2y plus 4, I can substitute negative 2y plus 4 in for x. Okay, so instead of writing 2 times x, I'll be writing 2 times negative 2y plus 4. Okay. So that's what we are doing here. We are going to substitute for x. Okay, so let's go ahead and write 2 times x is negative 2y plus 4. Okay, and then I can copy the rest of this down. Minus y equals 3. So minus y equals 3. Okay, and so now I have an equation with only y's in it instead of x's and y's. So now I can just solve for y. Distribute the 2, and I get negative 4y plus 8 minus y equals 3. I get negative 5y, combining like terms, plus 8 equals 3. Okay, and then here I can continue solving for y. So I'm going to subtract 8 on both sides. Cancel that out. So I get negative 5y equals negative 5. Divide both sides by negative 5. So y equals 1. Okay, but remember, what we're doing is we're trying to find the point that these two equations have in common, right? So I'm not done here because I only have the y coordinate of the point, right? So our answer needs to be a point, an xy coordinate, and we only have the y part. Okay, it's 1. So now I need to find the x coordinate. And the way you do that is once you have one of the coordinates, then you can plug that into any equation, right, that has the x and the y. It doesn't matter where. Whereas here, when you're doing the substitution, you must substitute into the other one. Okay, so you must substitute. If you got this here from the first one, you have to substitute it into the second one. Okay, but once you have your answer, remember, this is part of a point that works for both of these equations. So it doesn't matter where you plug this 1, you should get the same x value because it should be a point that works for both. Okay, so y equals 1, I'm just going to go ahead and use that first equation. Now solve for x. Okay, so that first equation, let's have a look at it. X plus 2y equals 4. X plus 2y equals 4. So I'm going to plug 1 in for y. Okay, so x plus 2 times 1 equals 4. X plus 2 equals 4. Subtract 2 on both sides. So x equals 2. So x equals 2. So that's my final answer. This is the point of intersection. Okay. All right. I'm going to have you guys try this one. And remember, you can always check your solution. Let's go back. You can always check the solution by plugging it into your system. 2 plus 2 times 1 equals 4. Yes, that works. 2 times 2, that's 4. Minus 1, that's 3. Yes, okay. So you can always check to see if your answer works in your system. It should satisfy all of the equations that are in your system. Okay, so let's go ahead and try this one. Solve by substitution method. Okay, and suppose that you have this for your, suppose you have this for your system. Y equals negative 2/3 x plus 2 and 4x plus 6y equals 24. Okay, so go ahead and give this a try. If something weird happens in the process, you can just stop and come back and we'll address that weirdness. Okay, so go ahead and give it a go. Hit the pause button. Okay, so for substitution method, this one's already solved for y. So I'm going to take this and substitute it in for y over here. Okay, so instead of writing 6 times y, I'm going to write 6 times all of this in parentheses. Okay. All right, so 4x plus 6 times y, and y, according to that first equation, is negative 2/3 x plus 2. Don't be afraid of those fractions. Okay, and then here, 4x, oops, my screen shifted. Okay, so 4x plus, when I multiply here, this is like a 6 over 1. So when I multiply here, the 3 and the 6 actually cancel, and I get 2 times negative 2. So that's going to be negative 4x. Okay, and then when I distribute here, that's going to give me 12. Okay, and so here's that weirdness that happens. 4x plus negative 4x is 0. So I end up with 12 equals 24. Hopefully you're going, no, it doesn't. 12 does not equal 24. Okay, so here, when something weird like this happens, okay, your variables just cancel out. They disappear. And then you're left with 2 numbers. Okay, if you end up with 2 numbers that are not equal, like 12 and 24, then you have no solution here, because 12 does not equal 24. So we have no solution. Okay, so the no solution case is the case where you have parallel lines, and so they are never going to intersect, so they don't have a common solution. Okay, so that's this case. These are parallel lines, and they do not have a common solution. 12 does not equal 24. Okay, so when you end up with 2 numbers that are not equal to each other, you have no solution. Okay, and this is that inconsistent case, right? Now, if you ended up with 12 equals 12, right? Your variables all cancel out and you're left with 2 numbers that are equal to each other, then that would be the case where you have the same line, one on top of the other. And so you have infinitely many solutions. Okay, so let's just put a little note there. Okay, so this here, this is not true. And if it's not true, then you have no solution. Okay, now note. Okay, if all your variables drop out and you're left with 2 numbers that are true, so you get true. So if true, like 12 equals 12, right? Had you gotten that instead, which is true, then you have infinitely many solutions. Okay. So just kind of make a note of that. You have the 2 cases. So this weird situation here where your variables drop out, You end up with two numbers not equal, no solution. You end up with two numbers that are equal, infinitely many solutions. Okay? All right, so that is substitution method. So part 2 is coming up next in a separate video, and that will cover elimination method. Okay, so I will see you in the next video.